Assalamualaikum. We are from MOHD, want to present our work for simulation assignment using Etap. First of all, my name is MOHAMAD and this is my group member, MOHD FARHAN, MOHD ZARITH and ZULHILMI. Okay, firstly, I will explain about question A, where we need to run load flow to determine the maximum current at each period. So this is our circuit. We set up the value of the circuit based on the given value for our group. Bus 1 and bus 2 voltage is 132 kV and 22 kV. The underground cable 1 and 2 is set up based on the given length and size. Induction motor 1 is set to 1500 kilowatt, while induction motor 2 is set up to 4000 kilowatt. The T1 and T2 capacity is set to 60 MVA. And also the vector for both T1 and T2 set to YY0. The value of ground resistance for both T1 and T2 is 8 ohm. Relay 1 until relay 5 using cement brand, relay 6 until relay 9 using Storm brand, and relay 10 until relay 13 using ABDUL brand. From that, we can find the maximum load current for each relay by clicking on the load flow symbol and then we run the load flow. The maximum load current produced at the relay is recorded in the table. For question B, we need to run short circuit analysis to determine the fault current at all buses. We just click on the short circuit symbol and run the 3-phase device duty. From that, we can find maximum fault current at each bus and also at each relay. The maximum fault current produced at the bus and relay was recorded in the table.
Hi, my name is MOHAMAD. Now I will continue in part C, which is to determine the transformation ratio of the CT, class 5P CT, and the accuracy limit current. So for bus 1, we got relay 1, which is we got the CT is 100/1, ALC 10A, and the class is 5P10. At relay 2, the CT is 100/1, ALC 10A, and the class is 5P10. At relay 3, the CT is 500/1, the ALC is 10A, and the class is 5P10. At relay 4, the CT is 500/1, ALC is 10A, and the class is 5P10. So for bus 2, we have relay 5 and relay 6. For the relay 5, the CT is 800/1, ALC is 20A, and the class is 5P20. At relay 6, the CT is 500/1, ALC 20A, and the class is 5P20. For the relay 8, the CT is 900/1, ALC 20A, the class is 5P20. For bus 3, we have relay 7 and relay 9. For relay 7, the CT is 600/1, ALC 20A, the class is 5P20. At relay 9, the CT is 900/1, ALC 20A, and the class is 5P20. For bus 4, we have relay 10 and relay 11. For relay 10, the CT is 100/1, ALC 10A, and the class is 5P10. Relay 11, the CT is 500/1, ALC 20A, and the class is 5P20. For bus 5, we have relay 12 and relay 13. The CT for relay 12 is 500/1, ALC 20A, and the class is 5P20. For the relay 13, the CT is 100/1, ALC 20A, and the class is 5P20. Now we are going to insert all of this value, which is CT ratio and the class at the network. Insert at relay 1, at relay 2, at relay 3, at relay 4, at relay 5, at relay 6, at relay 7, at relay 8, at relay 9, at relay 10, at relay 11, at relay 12, at relay 13.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZULHILMI and I will explain about our simulation assignment of part D. In part D, we require to determine the values of the pickup PU settings and time dial settings of all relays to ensure a coordinated protection system. Okay, in order to find the PU setting and time dial settings, we require to find the maximum load current, maximum fault current, and the CT ratio from the previous task. Okay, this is our table comparisons of all the requirement for our in order to find the PU setting and time dial setting. And we will use this in the formula. Okay, next. Okay, we starting by finding the ROT for the relay 13, 12, 11, and 10. This is the relay 13, 12, 11, and 10. It is in the bottom of the system. So we will find the first. I will explain the relay 13. How to get the ROT? We use the plug settings. We use the maximum load currents, which is 252.3, and we will get the PS setting. Then we find the pickup settings using the also maximum load currents, and then we find the relay setting currents RSI by using based on the pickup setting previously. This one value, and then we find the plug setting multiplier PSM by dividing the maximum fault current with the RSI. So we get this value, and then we use the formula of relay characteristic operating time RCOT. Which the formula is 0.14 divided by PSM with the power of 0.02 and -1. Okay, then we use the formula of RCOT to get its value, and then we will use the assumed time setting multiplier TSM 0.1, and then we will find the relay operating time by multiply the TSM with RCOT. Then for the relay 13, the ROT is 0.376. So but the value is negligible because of the relay 9. ROT relay 9, relay 12 is much higher from the relay 13. Okay, next we go to relay 12 by using the ZSM formula, and based on the previous tables, we will get the ROT equal to 0.420 seconds. Next, we will find the ROT for relay 11 and 10. Okay, for the relay operating time, ROT for relay 11 is 0.420, while the relay 10, the relay operating time ROT is 0.368 seconds. But this value is negligible. We neglect because of the relay X, because of ROT relay X at relay 11 is much higher with this value. Okay, that is for the bottom of the system. Relay 13, 12, 11, and 10. We already find the ROT. Okay, next we go to relay 9X. Relay 9 and X is in this system. It's influenced by the relay of 13 and 12. So for the calculation, we find the plug settings and pickup settings, and we find the RSI. Then we find the fault downstream of the of relay 12. We using the formula ROT at relay 9. We find the ROT at relay 9, and then PSM relay 9. And by using the formula R code, we find the R code at relay 9, and then TSM relay 9 at the relay 12. So we got the TSM 0.2761. Okay, so for the fault downstream of relay 9, we use the formula plug setting multiplier PSM, the fault current over RSI, and then we find the R codes and use the formula 0.14 over PSM, power of 0.02 minus 1, and then we find the ROT. ROT we got for this relay 9 and 8 is 0.911 seconds. Then we also apply the same procedure with the relay X. So we found the fault at relay 11 first. So we got the TSM, relay X is 0.5518. And then we find the fault downstream of relay 8. So the relay operating time ROT that we got is 1.687 seconds. Okay, next. Okay, relay 7 and 6 is, in this one, is influenced by the relay 11 and 10. So this is 6 and 7. Okay, we find the plug settings. We find the ROT using the with the same formula: plug setting, pickup setting, RSI, TSM, and R codes. We get the 4.182. The time setting multiply TSM, we got 0.2761, and the relay operating time ROT we got for the relay 7 is 1.155 seconds. So for the relay 6, the R codes is 4.201, and relay operating time ROT we got 2.318 seconds. Moving on to relay 5. Okay, the condition of the relay 5 is here. Okay, so we use the formula of we're finding the plug setting first and pickup settings is 25. Okay, so we find the RSI which is 200. Then we find the fault downstream of relay 6. So this is the formula. So and then we got the TSM relay 5 at relay 6 is 0.7537. Okay, then for the fault downstream of relay 5, we find the PSM, R codes, and finally the ROT is 1.180. Next, we go to relay 4 and 3. The relay 4 and 3, the condition is here. Okay, we can see that using the same plug setting, find plug setting, pickup settings, and the relay setting current is 250. So we find the fault downstream of relay 5, and then we got the TSM. We find the ROT, PSM, relay 4, R codes, and find the TSM relay 4 which is 0.955. Then for the fault downstream of relay 3 and 4, we find the PSM 17.956 and relay characteristic R code with 2.355, and ROT for the both relay 3 and 4 is 2.25 seconds. The final one is relay 2 and 1. The condition is here, 2 and 1, relay 2 and 1. Okay, we find the plug settings, pickup setting, and the relay setting current SI is 175 for the both relay 2 and relay 1. And then we go to fault downstream of relay 3 and 4. We find the ROT, PSM, R codes, relay 2, and then for the TSM relay 2 on the relay 2 1 is 1.365. Next, we found the fault downstream of relay 1 and 2. We find the PSM and R codes which is 5.63, and finally we will achieve relay operating time ROT with 7.68 seconds. Okay, this is our table of comparisons of each relays and its pickup current as I. And this is the time diode test. You can see from the table, from relay 13 to the relay 1, pickup currents differs with each other. And the time dials, we can see from the relay 1 to relay 13, the time dial is decreasing. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is MOHD FARHAN from NIZAM. For my part, I will show the time current coordination curve and the sequence of operation for fault at each bus. So for the time current coordination curve, we move to the Etap software. To view the current curve, at first we go to the star protection and coordination. We click on that, and then we click on the star system to view the graph of the time coordination current system. Firstly, we display the grid by the grid already displayed. Based on the plot, we can see that this vertical axis is represent the time in second, while for the horizontal axis it represent multiple of rated current. So this is the curve for the relay 1. Okay, next the relay 2, relay 3 curve, relay 4, relay 5, so as we can see, the curve will turn red when we click on the button that related to the relay. This is for the relay 6, relay 7, relay 8, relay 9, relay 10, relay 11, relay 12, and last but not least, the relay 13. Basically, long time tip value will respond to overcurrent, while short time tip and instantaneous tip will respond to the short circuit. In addition, all the relays characteristic is shown in standard inverse characteristic. So it call IDMT relay, which the operating time is approximately proportional to the fault current. I think that is it for the part E. Okay, last but not least, for the sequence of operation for fault at each bus, we move to the Etap software. Firstly, we use the fault insertion and click on the desired bus. For the first bus, I will click on the bus 5, and after that, we use the sequence viewer to see the fault sequence. Okay, as we can see, the first fault is occurred at relay 1, followed by relay 2 and relay 3. And the value of the relay operating time, ROT, is 15.7 milliseconds, and it is same as the relay 2 and 3. These values are just the same as our calculation for the previous part of the video. Next, we will go to the bus 4. For the bus 4, the first fault is occurred at relay 1, followed by the relay 2 and relay 3. We move to the bus 3. The first relay is relay 1, and the second one is relay 2, and then relay 3. For the bus 2, it is just the same as the bus 3. And for the last bus, which is the bus 1, the first relay is also relay 1, and relay 2, and relay 3. Okay, the second relay at each bus for power system network has been complete. As the result, our simulation of this power system network worked almost precisely. We obtained the accurate maximum current at each feeder, the correct fault current at each bus, the correct transformer current, also for the time dial and pickup time setting, time current coordination curve, and lastly, the sequence of relay operation at each bus. All of our parameters could be justified with some evidence and explanation. That's all from us. Thank you.